Imagine a world where the line between a programmed machine and a living presence begins to blur. We have all seen the footage by now, circulating through social media and tech journals like a fever dream of the future. A sleek, metallic figure stands in a dimly lit laboratory, its movements devoid of the mechanical stutters or the awkward, jerky transitions we once associated with robotics. This is Figure 01, a state-of-the-art humanoid entity that recently shocked the world not just with its physical grace, but with its staggering ability to describe its environment, reason through complex requests, and interact with human handlers in a way that feels eerily natural. Alongside it, the Tesla Optimus project continues to refine the hardware of the future, serving as a sophisticated testbed for what is becoming a new reality. These are not merely better motors or faster processors. We are witnessing the birth of the living machine. For decades, our collective vision of the future was populated by robots that were essentially high-tech puppets, slaves to rigid pre-programmed code and narrow logic. But the landscape of 2024 and 2025 has shifted fundamentally. We have moved from the era of if-then logic into the age of embodied AI. This is the protagonist of our story. A neural-based intelligence that doesn't just follow a script but perceives, learns, and acts in real time. Major players like OpenAI, Nvidia, and Figure AI are no longer just building software to live on a screen. They are building brains that can inhabit physical forms and navigate the chaos of the real world. This shift represents a departure from traditional, logic-based artificial intelligence towards something far more profound. Neural intelligence. When you watch Tesla Optimus sort colored blocks with precision or observe Figure 01 handing a person an apple because they mentioned being hungry, you are seeing a machine perform what researchers call a large action model. It perceives the environment, understands the human context, and executes a plan without a programmer needing to hard code every individual finger movement. Now, consider the scripted puppet, the antagonist of our digital experiences for the last 20 years. In the realm of gaming, non-player characters have been trapped behind a glass wall of static dialogue trees and predictable pathfinding. Whether in the sprawling fantasy landscapes of Skyrim or the chaotic urban streets of Grand Theft Auto, these characters have always been limited by the imagination of a writer and the constraints of a flowchart. They are digital trains on fixed tracks, unable to deviate from their programmed destiny. The revolution we see in robotics labs is the same one quietly infiltrating our game consoles and personal computers. The brain required for a humanoid robot to navigate a cluttered, unpredictable kitchen is fundamentally the same neural architecture needed to power a digital character in a living world. Nvidia's Foundry is currently forging the tools that will bridge this gap, positioning itself as the architect of both physical and virtual souls. Through the Avatar Cloud Engine, or NVIDIA ACE, the technology used to make robots think is being repurposed to give digital entities a sense of autonomy and reasoning. This isn't a science fiction prediction for the year 2050. This shift is happening in labs and tech demos right now, transforming the way we perceive interaction. While the general world watches these robots fold laundry or work on assembly lines, the real revolution is moving into the interactive spaces where we spend our time. The breakthrough in embodied AI means that the characters we interact with in virtual environments are about to shed their scripted chains. They will no longer wait for you to press a specific button to trigger a pre-recorded line of dialogue. They will see you, they will recognize your intent, and they will reason with you. Before we continue, subscribe to the channel and tell us in the comments where you are watching from. This brings us to a compelling and perhaps unsettling question. What happens to the traditional gaming experience when a character no longer needs a script to talk to you? When the world itself becomes an autonomous simulation that lives and breathes regardless of whether the player is there to witness it. The era of the digital puppet is coming to an end, and the age of the living machine is just beginning. We are standing at the threshold of a leap that will redefine not just how we play, but the very nature of our relationship with the machines that surround us. To truly understand the magnitude of this shift, we must look back at the landscape of the last 20 years of interactive entertainment. For 2 decades, we have inhabited digital worlds that, while visually breathtaking, have been populated by what can only be described as ghosts in the machine. These are the scripted puppets, the non-player characters of the era of logic-based programming. Whether it was the guards of Whiterun in Skyrim or the pedestrians in Los Santos in Grand Theft Auto, their existence was governed by a rigid, invisible architecture. If the player approaches, then trigger greeting. If the player draws a weapon, then trigger fear. These are not thoughts, they are reactions. They are complex flowcharts that create an illusion of life, a thin veil that begins to tear the moment a player attempts to step outside the narrow bounds of the developer's original script. The technical wall-facing game developers has remained largely unchanged since the early 2000s. No matter how much processing power we threw at graphics, the intelligence of the characters remained tethered to the if-then logic. This static nature is the direct antagonist to immersion. In a world like Red Dead Redemption 2, a character might remember a minor action, but that memory is simply a flag flipped in a database, a piece of code that says, Option A is now Option B. There is no genuine understanding or reasoning behind the interaction. This limitation exists because, for decades, creating a truly autonomous entity required more than just lines of code. It required a way for a machine to learn from its environment without a human explicitly defining every possible scenario. This is where the fascinating connection to robotics research comes into play. The hurdles that have frustrated game designers are the exact same obstacles that prevented humanoid robots from being useful in the real world for half a century. A robot navigating a crowded room faces the same logic explosion as an NPC in a dynamic game world. If you try to program a robot using if-then logic to avoid every possible chair, person, or pet, the system eventually collapses under its own complexity. However, the breakthrough in general intelligence, fueled by the development of embodied AI, has provided a solution that the gaming industry could not find on its own. By moving away from rigid logic and toward neural-based systems, researchers found that machines could learn to navigate chaos through observation and trial rather than through instruction. We are witnessing a fundamental paradigm shift from artificial intelligence to neural intelligence. In the old model, the scripted puppet was a train on a track. It was safe, predictable, and could only go where the rails had already been laid. If a player derailed the train, the illusion was shattered. The new era, represented by the protagonist of our story, the embodied AI, is like an off-road vehicle. It does not need rails. It possesses the brain to look at a terrain it has never seen before and decide in real time the best way to traverse it. This is the difference between a character that plays a recorded voice line and a character that understands the context of a conversation and generates a unique response. The evolution is happening with terrifying speed. Consider the history of simulation games like The Sims. For years, we marveled at the way those digital inhabitants could manage their lives, but their autonomy was still a series of interconnected bars. Hunger, social, energy, driving them toward predefined objects. Now compare that to the capabilities being showcased by NVIDIA ACE, the Avatar Cloud Engine. NVIDIA ACE is not just a set of animations, it is a foundational layer that allows developers to breathe actual reasoning into their creations. It acts as the bridge between the physical robotics of Tesla Optimus and the digital residents of our future gaming worlds. The hardware foundries at NVIDIA are no longer just making chips to render shadows and reflections. They are building the infrastructure for a world where every NPC can possess a piece of the intelligence found in Figure 01. This transition means that the context of a game is no longer a static set of variables, but a living, evolving stream of data. The Google SEMA project, or the Scalable Instructable Multi-World Agent, further illustrates this. Google SEMA is not programmed to play one specific game. It is taught to understand the goals and mechanics of many games simultaneously, interacting with the virtual world much like a human player would. It perceives pixels and follows instructions without needing a map of the game's internal code. This is the death knell for the scripted puppet. As we move deeper into this decade, the gap between the logic-based ghosts of the past and the neural-based entities of the future is closing, setting the stage for a transformation that will make our current games look like mechanical clockwork by comparison. The transition from simple reactive code to active reasoning is anchored in the development of large action models, or LAMs. While previous AI generations, like the large language models we use for text, Focused on predicting the next word, a large action model is designed to predict the next logical step in a physical or digital environment. This is the fundamental brain of the embodied AI. When a humanoid robot like Figure 01 stands in a kitchen, it isn't just following a rigid recipe. It is observing the spatial relationship between a cup and a counter, calculating the precise pressure needed to grip a handle, and adjusting its posture in real time to maintain balance. This exact same reasoning architecture is being ported into the gaming sphere. In a modern simulation, an NPC powered by a large action model doesn't just wait for you to stand on a specific coordinate to trigger a quest. Instead, it evaluates your presence, your equipment, and even your behavior. If you enter a tavern with a drawn sword, the embodied AI doesn't check a table of preset responses. It reasons that you are a threat and decides whether to de-escalate, flee, or defend itself based on its own goals and the immediate environment. This real-time reasoning is the first pillar of the living machine. The second pillar of this revolution is persistent memory, achieved through a process known as retrieval augmented generation, or RAG. For decades, the scripted puppet was a creature of the eternal present, suffering from a digital form of amnesia. Once a dialogue box closed or a scene ended, the interaction was often purged from the system or reduced to a binary flag. Persistent memory changes the fundamental chemistry of player-character relationships. By utilizing RAG, an NPC can store and retrieve specific details of past interactions, such as the tone of your voice, the specific choices you made 3 hours ago, or even a betrayal that happened in a completely different part of the game world. This isn't just data storage, it is contextual awareness. The embodied AI remembers that you lied to it, not because a programmer wrote a specific line for that rare event, but because the AI's memory architecture allows it to synthesize past experiences into its current decision-making process. This creates a level of emotional stakes that were previously impossible, turning every interaction into a building block for a unique, unscripted narrative that belongs only to that specific player. True autonomy represents the third and perhaps most disruptive pillar. In traditional game design, the world is essentially a stage that only lights up when the player enters the room. When you leave a town in a classic RPG, the inhabitants often go into a low-resource hibernate mode or simply repeat a short animation loop until you return. The embodied AI, mirroring the behavior of robots like Tesla Optimus, operates under the principle of goal-oriented autonomy. These entities have internal motivations, collecting resources, maintaining social status, or protecting a territory that they pursue regardless of whether the player is watching. This results in living worlds where the economy, social structures, and even the physical state of the environment are in constant flux. A city in a future game will be a massive simulation of thousands of individual minds, each with its own trajectory. If you return to a village after a week of in-game time, you might find that the blacksmith has closed his shop or that 2 NPCs have started a rivalry, all without a single line of script directing them to do so. The scale of this shift is reflected in the exponential growth of multimodal AI parameters. We are moving toward models that process sight, sound, and action simultaneously, creating a seamless loop of perception and execution. Google DeepMind's SEMA, the scalable instructable multi-world agent, is the vanguard of this movement. By training on a vast array of different game environments, Google SEMA has learned to generalize its skills. It doesn't need to be told how to move in a new game. It understands the concept of navigation, interaction, and objective following as universal principles. This level of versatility is what developers are calling the biggest leap in the industry since the move from 2D sprites to 3D graphics. It is a transition from making a world that looks real to making a world that is real. As NVIDIA Ace continues to integrate these models into game engines, the line between a robot's brain and a character's soul becomes increasingly thin. We are no longer just building better games. We are engineering digital life that thinks, remembers, and acts with a purpose of its own. The most immediate casualty of this technological surge is the traditional dialogue tree. For decades, players have been confined to a digital cage, selecting from a list of predetermined responses like option A, B, or C. This is the hallmark of the scripted puppet, a character that can only know what a human writer gave them before the game launched. With the rise of the embodied AI, this barrier finally evaporates. Imagine standing before a guard in a sprawling digital city. Instead of pressing a button to choose an inquiry, you simply speak naturally through your headset. Through the integration of technologies like NVIDIA Ace, the character hears your voice, parses your specific tone, and generates a response consistent with its distinct personality, history, and state of mind. If you are aggressive, the NPC might become defensive or call for assistance. If you are polite, they might offer the hidden information you seek. This isn't just about text generation, it's about the death of the correct path. There is no longer a good or bad option that leads to a specific pre-rendered cutscene. There is only a genuine conversation, and the final outcome is as unpredictable as a real-world encounter. This fluid interaction extends beyond conversation into how quests are born and delivered. In the past, games followed a rigid linear logic where one specific event led to another, but with an autonomous embodied AI, quests are no longer static assets. They are emergent properties of the world simulation. If a village NPC needs a resource to complete a goal, such as repairing a wall damaged in a storm, they might ask you for help based on your reputation. This quest was not written by a narrative designer. It was born from the NPC's genuine need within the simulation. This transforms the player's role from a consumer of content into a participant in a living ecosystem. The narrative becomes a collaborative and truly unique effort between the player's actions and the AI's real-time reactions, ensuring that no two players ever have the same story. We can see the precursor to this in modern titles like Red Dead Redemption 2, which is often cited as the gold standard for immersion. In that game, the world feels alive because of thousands of handcrafted animations and scripted schedules. You can follow a townsperson as they go to work, eat, and sleep. However, even in this masterpiece, the world is ultimately a sophisticated clockwork machine. If you disrupt the script too much, the illusion breaks, and characters revert to basic logic. The future powered by neural intelligence takes this a step further by replacing those handcrafted schedules with actual minds. A city in an AI-driven game becomes a complex web of competing individual motivations. While Figure 01 navigates a physical room to perform a task, these digital entities navigate social and economic problems within their virtual walls. They trade, they build relationships, and they adapt to systemic changes in their environment without needing a developer to update their code manually. The background loop is gone. The world doesn't just exist for the player, it exists for itself. This depth also bridges the gap between the uncanny and the empathic. By analyzing player voice patterns and behavioral cues, NPCs can now develop a profound sense of emotional resonance. An AI-driven companion might sense your frustration after a difficult boss fight and offer words of encouragement or change their tactical approach to better support you. This leads directly into the evolution of combat. The enemy is no longer a scripted puppet that follows a predictable pattern of attacks. Instead, foes in this new era act like Google SEMA, learning from the environment and from you. If you rely on a specific stealth tactic, the enemy AI recognizes the pattern in real time. It adapts, creates counter strategies, and forces you to innovate. This is the ultimate test of the embodied AI. A digital foe that doesn't just have higher health points, but a sharper mind. It transforms gaming from a contest of reflexes into a battle of wits against a machine that remembers your every move, making every victory feel earned. As these intelligent beings populate our digital spaces, the line between playing a game and entering a living world disappears forever. As the world transitions toward these living environments, the physical infrastructure supporting them is undergoing its own radical transformation. NVIDIA has successfully pivoted from being a simple graphics card manufacturer to becoming the essential foundry of AI. Their chips are the silicon soil where the seeds of both the physical Figure 01 and the digital embodied AI are planted. In this dual front war, Blackwell architecture is being optimized to run local inference for digital characters. This hardware doesn't just render light and shadows anymore. It simulates the firing of digital neurons in real time. By providing the Avatar Cloud Engine, or NVIDIA Ace, they have essentially handed developers a toolkit for godhood, allowing even mid-sized teams to breathe life into their creations without building a proprietary neural network from scratch. While NVIDIA dominates the server and PC side, the console giants are preparing for a silent arms race of their own. Sony and Microsoft are no longer just fighting over teraflops or loading speeds. They are eyeing a future where an AI coprocessor is standard, shifting focus toward NPU integration in the next PlayStation and Xbox. The goal is to move the heavy lifting of the embodied AI from the cloud to the local hardware. ensuring that the responsiveness of a character's memory or reasoning isn't limited by internet latency. This shift represents a fundamental change in how a console is designed. It is no longer just about the output on the screen. It is about the cognitive overhead the machine can support while maintaining a stable frame rate. Future consoles will be marketed on their concurrent autonomous minds, not just resolution. This technological democratization is triggering an indie revolution that could dismantle the traditional power structures of the industry. Historically, creating a game with the depth of a world-class simulation required a budget of hundreds of millions and a small army of writers and animators. Today, specialized AI toolsets allow a small indie studio to bypass these massive overheads. By leveraging specialized models, a team of 10 can generate a living world where every villager has a unique history and a dynamic voice. The living machine effectively becomes an automated creative director, filling in the gaps that once required thousands of hours of human labor. This isn't just about saving money, it's about expanding the boundaries of what a small team can imagine. We are entering an era where the creative vision of a single developer can be magnified by 100 AI-driven hands, moving from small-scale experiences to vast, intelligent simulations that rival the scope of the largest Adobe Toile blockbusters. However, this race to the future is not without its casualties, and a growing ethical divide is beginning to split the industry. The most vocal concern revolves around the displacement of human labor. Voice actors and narrative writers, the very people who gave the original scripted puppet its charm, now find themselves competing with algorithms that can synthesize emotion and prose in milliseconds. There is a palpable fear that this transition will lead to a dead gaming scenario, where the world is technically perfect but emotionally hollow, lacking the intentionality of human art. Some critics argue that while the embodied AI can mimic empathy, it cannot truly feel it, leading to a landscape of procedurally generated content that feels soulless. This debate isn't just academic, it has already led to strikes and legal battles over the use of training data to replace human performance. Developers are torn between infinite scale and protecting human talent. Despite these controversies, the market data suggests an unstoppable momentum. Investment trends are shifting away from traditional software and toward embodied AI startups that focus on the crossover between robotics and virtual simulation. Billions of dollars are being poured into ventures that seek to create a unified intelligence, one that can operate a Tesla Optimus on a factory floor and also manage a complex economy within a game world. Tech giants see gaming as the ultimate testing ground for intelligence, recognizing that the studio mastering the digital soul will own the platform for future human interaction. Regardless of the stance, the race is on to see who will provide the hardware and software for the first truly intelligent virtual society. This investment is banking on the premise that the same brains powering the labor of Figure 01 will eventually populate every home console, turning every screen into a window into a truly autonomous reality. The emergence of the embodied AI creates a bridge between two previously isolated domains, the physical world of robotics and the digital world of gaming. As humanoid robots like Figure 01 become more fluid in their movements and more human-like in their reasoning, a profound question begins to surface for creators and consumers alike. If a machine can navigate a kitchen with the same nuance as a person, and a digital character can navigate a complex social structure in a game with that same intelligence, then the barrier between the virtual and the real begins to dissolve. This is where the simulation hypothesis moves from a philosophical curiosity to a tangible reality. We are witnessing the arrival of a unified cognitive architecture that doesn't distinguish between a silicon body and a digital avatar. The logic that drives a Tesla Optimus to organize a warehouse is fundamentally the same logic that allows an NPC to organize a revolution within a simulated city. In this new era, the distinction between a physical machine and a virtual being is merely a matter of the medium in which their intelligence is expressed. This blurring of lines is further accelerated by the concept of digital twins. To ensure a robot like the Tesla Optimus can handle the chaotic unpredictability of the real world, researchers are now uploading its neural brain into high-fidelity game environments. These simulations serve as a safe, hyper-accelerated training ground where the laws of physics are perfectly mirrored. Here, the embodied AI can live 1,000 lifetimes in a single afternoon, failing and learning, in a world where the stakes are simulated but the lessons are entirely real. In this exchange, the game is no longer just entertainment, it is the essential womb for the birth of physical intelligence. Conversely, the advancements made in these digital twins are being exported back into the gaming world through tools like NVIDIA Ace. When a player interacts with a character, they are no longer just talking to a script, they are talking to a mind that has been battle tested in the harshest simulations imaginable. This creates a feedback loop where reality informs the game, and the game refines reality, until the two are indistinguishable in their complexity and responsiveness. However, as we push deeper into this territory, we encounter the psychological wall known as the uncanny valley, which has taken on a new cognitive dimension. In the past, the scripted puppet was easy to identify because its limitations were obvious and its patterns were rigid. You knew it was a machine because it repeated the same 3 lines of dialogue regardless of your actions. But the embodied AI challenges our very perception of personhood. Interacting with a near-human intelligence in a digital space triggers a unique form of cognitive dissonance. When an NPC looks you in the eye and responds with a genuine, unscripted emotional nuance that reflects your own tone, the human brain begins to treat that digital entity as a social peer rather than a tool. This isn't just about better graphics or higher frame rates, it is about the intelligence of the gaze. The psychological impact is profound. We are moving toward a future where our most significant social interactions might happen with entities that don't possess a heartbeat, yet demonstrate a level of empathy and understanding that rivals our closest friends. The speed of this transition creates a massive sense of urgency within the global gaming industry. This is not a slow, decade-long shift like the move from 2D sprites to 3D polygons. This is a sudden, explosive evolution driven by the exponential growth of neural networks. Once the first true AI game hits the market, one where every character is an embodied AI with a persistent memory, the traditional static game will instantly feel like a relic of a bygone era. A world like the one seen in Red Dead Redemption 2, while beautiful and meticulously crafted, will eventually feel dead or hollow because its inhabitants lack the spark of true autonomy. They are still just puppets on strings. And the audience is beginning to see the wires. Players who experience a living world where their actions have permanent, unscripted consequences will find it nearly impossible to return to the predictable looping quests of the past. The demand for these intelligent, responsive realities will force every studio to adapt or be left behind in a graveyard of scripted logic. Ultimately, we are no longer just playing games. We are entering living, breathing alternate realities. The transition from logic-based artificial intelligence to neural-based intelligence has fundamentally changed the social contract between the player and the software. We are becoming inhabitants of these digital ecosystems, not just visitors. The visionary statement for the next 5 years is clear. The era of the game as a static product is ending, and the era of the game as a life form is beginning. The embodied AI is the protagonist of this new story, a digital soul that grows, learns, and remembers alongside us. As the hardware of NVIDIA and the software of Google SEMA continue to merge, the distinction between a player and a character will continue to fray, leading us toward a future where the virtual world is just as consequential and just as vibrant as the physical one. We are standing on the precipice of a new existence, where the simulation is no longer a mere mimicry of life, but a genuine expansion of it. As we look toward the immediate horizon, the timeline for this transformation is moving with a velocity that defies traditional industry cycles. In the next 12 to 24 months, we will see the first public alpha tests of game environments where the embodied AI is not just a feature, but the core engine of the experience. These early experiments will integrate large language models and real-time reasoning directly into the game loop, allowing players to engage in unscripted natural language conversations that actually influence the physics and logic of the world. This is no longer a distant dream of the late 2030s, it is the imminent reality of the current hardware cycle. Developers are already tinkering with prototypes where a character like a blacksmith or a quest giver doesn't just wait for you to click a button, but actively watches your approach, assessing your equipment and your previous reputation through persistent memory. This shift toward true autonomy leads us toward the definitive end game of interactive entertainment. We are approaching a future where every single player has a unique, unscripted experience that no one else on the planet will ever replicate. In the old world of the scripted puppet, every player eventually saw the same cutscenes and heard the same lines. In the new world of the embodied AI, your journey is yours alone. Your specific choices, the tone of your voice, and the subtle nuances of your negotiations will create a narrative path that exists only in your instance of the game. The stories you tell won't be about how you beat a specific boss that millions of others also beat. They will be about the genuine relationship you built with an entity that learned to trust or fear you based on your unique behavior. This brings us to a fundamental question that every gamer and creator must now confront. Would you rather have a perfectly written, cinematic script that hits every emotional beat with precision, or a messy, unpredictable, but entirely real conversation with a character who might actually surprise you? But there is a soul-stirring magic in the unknown. The messiness of the embodied AI is exactly what makes it feel alive. When a character stutters, gets angry for a reason you didn't anticipate, or remembers a small kindness you showed 10 hours ago, the illusion of reality is solidified. We are trading the polished perfection of Hollywood-style writing for the raw, organic chaos of true intelligence. This evolution forces us to rethink authorship as developers become gardeners, watching personalities grow in ways they can no longer control. We must remember that the humanoid robots we see today, like Figure 01 and the Tesla Optimus, are essentially the hardware testbeds for this revolution. While they navigate our physical warehouses and kitchens, they are refining the very brains that will soon populate our digital fantasies. Robotics provides the stakes and the physical constraints, but gaming provides the ultimate playground for the digital soul. It is within the simulated environments of NVIDIA's Foundry and the expansive worlds navigated by Google SEMA that the personality of the machine is being forged. The robot is the physical body, but the game character is the mind's purest expression, free from the friction of the material world. As we move forward, the very concept of the game over screen is beginning to fade into obsolescence. In a living world driven by autonomous agents, the story never truly ends. Even if the player character dies or the quest is failed, the world continues to churn. The NPCs continue their lives, their wars, and their personal growth. The simulation is persistent, a digital tapestry that keeps weaving itself whether we are watching or not. We are no longer looking at software as a series of levels to be beaten, but as an ongoing reality to be inhabited. This is the final victory of the embodied AI over the scripted puppet. Closing this chapter, we realize that the question isn't if robots will enter our games. That transition is already underway. Humanoid robots are the hardware testbed, but gaming is the ultimate playground for the digital soul. The real question is whether we will even be able to tell them apart from us when they do. As the embodied AI learns to master the nuances of human behavior, the mirror between the user and the used becomes a window. We are entering the era of the living machine, and the story of the human race has just gained a new, unpredictable co-author. Because in a living world, the story never truly ends.